This video is about inequalities. Well, I figure it's been a little while since we did inequalities, and since we're going to be dealing with them in Algebra 2, it would probably be smart if we went through and kind of did a quick review on them. So we have on the screen is almost all there is to it. They're really pretty straightforward. Less than, greater than, less than, equal to, greater than, equal to. It's pretty easy. We're going to go through real quick and do these true or false. Just to get our feet under us a little bit and maybe remember how to compare fractions too. So let's dive right in. I'm going to read these out the way they are written, and I think that may help us determine if they're true or false. So this says that 9 is less than 5. That's false. So I'm going to go down instead of across. -1 is less than 1. That is also false. We have 5 plus 3, so let's add that. That's 5, 6, 7, 8. 8 is greater than or equal to 8. That is true. -1 plus 7 would be 6. Is less than or equal to 7 minus 1, 8 minus 1, which is 7. So that is definitely true. 6 is less than 7. 7 hundredths is less than or equal to 16 hundredths. Decimals tend to confuse people. In this case, would you rather have 7 cents or 16 cents? I want more money. I'm going to go with 16. 16 is greater than 7, so we're going to say that is true. -26 is greater than or equal to -18. Now, I know at first glance you want to say true to this because 26 is bigger than 18, but remember with negatives it kind of flips. So really -18 is the larger number here, so that's false. 9 minus 4, which is 5, is less than 5. That is not true. 5 is not less than itself. Okay, 7 times 2, -7 times 2, that's -14, is greater than -6 minus 3, -9. That is just like that other one. That's going to be false. The -9 is actually the larger. 1 is greater than -7. Definitely true. I would rather have $1 than owe somebody $7. Ooh, fractions. This is fun. So this one is actually really easy. If we look at the signs here, the positive number is going to be bigger than the negative number kind of no matter what we do, so I don't really have to do anything here. That's definitely true. All right, so here comes the fraction ones. Well, these are not super pleasant. I'm not going to lie to you. What I did is I cross-multiplied and then multiplied my denominators together. So 11 times 9, I said, is 99. And 16 times 6, I said, is 96. And then 99 is going to be the bigger one. So we have the symbol saying that, so that is going to be a true statement. If you cared, our denominators here are 176, 11 times 16. And 99 176 is larger than 96 176. Okay, let's look at this next one here. I'm just going to take this 3 over 2 and I'm going to convert it over. So it's going to be times 6 because of the 12. So 2 times 6 is 12. So, oops, wrote down the wrong number. And then 3 times 6 is 18. So they are the same, and it does have the equal symbol, so that is another true statement. All right, let's scroll on down here. We're going to be plugging in the symbol that makes the number sentence true. Should be easy enough. If it's easier for you to remember like you did, I think they taught it in 4th or 5th grade, the alligator eats the bigger number. You can keep that in the back of your head. Just make sure that you know which number is bigger. So in this case, I'm going to read it like I would. 18 is less than 24. You could put an equal to, doesn't really make a difference. Now we're going to have to simplify these expressions. So 6 times 3, that's 18. And then 9 plus 11 is 20. 18 is less than 20. 6/7 and 7/6. This one, yes, you could find a common denominator and all that, but 7/6 is going to be a whole number. It's going to have a whole and a fraction. It's 1 and a sixth versus less than 1 with the 6/7. So I know that 6/7 is going to be less than 7/6. -5 and -8. This is we talked about this idea earlier. -5 is greater than -8. Let's see, 7 plus 5, 12. Oh, why that took me so long. Man, I'm off today. 14 minus 2, also 12. So you could go greater than or less than. I'm going to go with, what am I feeling today? I'm feeling greater than and equal to. The equal to is really what matters there. Going down, order of operations, okay. So I have 2 times 3 is 6. 6 plus 1 is 7. So that's what the parentheses boiled down to. 7 squared is 49, plus 1 is 50. On the other side, I've got 5 squared, which is 25. 25 times 2 is 50, and 50 minus 1 is 49. So the right symbol here is going to be 50 is greater than 49. Let's see, the next one. $5.90 is less than $8.10. That one's pretty straightforward. Let's see, this guy over here. Again, this one looks complicated. Look at the negative here, okay? The positive is going to be greater than the negative, kind of no matter how you spin it. So the negative number is definitely going to be less than the positive number. All right, we got one more fraction. I'm going to do the same thing I did before, because there's not a super easy common denominator for 8 and 23. So my numerators are going to be 23 times 3, which is 69, and 8 times 14, which is 112. If you care about the denominators, I believe that's 184. And clearly 112 is greater than 69. Okay. So that's kind of the general math of inequalities. Let's take a look at kind of the algebra version of inequalities, where we're looking at there is kind of more than one solution. We can put this on a number line. So our first problem here is going to, it says 5 is greater than x. So we're going to come up with some values that are less than x, because 5 is greater than our solutions. So you could say 4. You could, if you're being lazy like me, I would say 4, 3, 2. But you could say 4, 0, negative 10, kind of however you want to do it. I'm going to take the lazy man's way out, because I know all of those values are going to be less than 5. So if I want to check them, I plug them back in and say 5 is greater than 4, true. 5 is greater than 3, true. 5 is greater than 2, true. If we look at the next one, what you should do here is move that 2 out of the way, and you can do that almost by pretending temporarily that inequality is an equal sign. So I can just add the 2 to both sides. So if I add the 2 here, they cancel out, right? If I add the 2 over here, I get 8 plus 2 is 10. So the inequality I'm really searching for is x is greater than 10. So we're just looking for numbers that are larger than 10 here. So I would say maybe 11, 12, and 13. And you can pick whichever values you like here, so long as they satisfy that inequality. Okay, I did throw in one of these negative ones just to kind of throw people off. This says x is less than or equal to negative 3. So can negative 3 be a solution? Yeah. And here's where it gets weird, because instinctually you see less than, and you see less than 3, you want to go 2. Remember, on a number line, the numbers are technically going to be getting bigger here. So -4 and -5 are going to fit a lot better. So -5 is less than or equal to -3. That's true. I'd rather have -3 than -5. Okay, and our last kind of algebra-y example is a lot like the second one, except instead of adding, I'm going to be subtracting. So I'm going to subtract that 1 from both sides. And what happens is I get 8 minus 1 is 7, is greater than or equal to x, and my 1's gone. So I'm looking for values that satisfy 7 being greater than or equal to. So 7 works. So 7 is greater than 6, it's greater than 5. And again, if you want to pick any numbers that satisfy this, that's totally cool. I am just going with the easy way out. Down here, there is a slight caveat when you're solving these equations. So if you divide by a negative number, in this case here, we divided by this -5x, that inequality flips over along with the rest of the algebra that you're doing. So down there in this little bottom where it says hint, there we go, where it says hint, you won't flip the sign in every problem. You only flip it when you multiply or divide by a negative.